Well, welcome. I'm JJ. Let's do an example problem. So we are doing more 3D vectors for statics. In this problem, we are trying to figure out for our two forces. Let's first express each as a Cartesian vector. So one force goes from A to B. We know the coordinates there. We can work towards a Cartesian vector. Same idea. One goes from A to C. Let's get a Cartesian vector there. Then we're going to try to get to what's the magnitude and coordinate direction angles, those alpha, beta, gamma angles of a resultant vector. So we're going to have to add my two vectors together, get a resultant vector, find a couple more pieces out from it then. So let's jump in and go for it. If I'm doing this, the first thing I would try to do, let's get those Cartesian vectors. So our very first step, number one, should just be, let's find our position vectors. Position vectors. And their magnitudes. And magnitudes. If I can get my position vectors and their magnitudes, I can use that to figure out my unit vectors. I can then get to a force vector, which would be my Cartesian vector then. So I need an RAB going from A to B. B is the tip, A is the tail. So a position vector R that goes from A to B. This would be the tip is B, the tail is A. We want to do tip minus tail. So this would be equal to, this is distance. We are in, it doesn't say it, oh it does, meters. In one of our points it says it. We're in meters for everything. But so I want to do 0 minus 0 in the I. B minus A, tip minus tail would be 0 I. Plus 0 minus 2 will be minus 2J. Plus 0 minus 4 minus 4K meters is my position vector from A to B. If I know that, I can get my magnitude of RAB figured out as well. This should be the square root of my I component squared, 0 squared, plus 2 squared, plus 4 squared. Again, I'm ignoring the negatives because when I square it, they will go away anyway. But this will get me to 4.472 meters. If I know that, I just want to repeat that for my other position vector. I have one vector that goes from A down towards C. So let's find an RAC. So now I'll do C is the tip because my arrowhead points down towards C. A doesn't have an arrowhead on it, it's the tail. So C minus A. 4 minus 0 is 4I. 8 minus 2 will be plus 6J. And 0 minus 4 will get me minus 4K meters. With that one known, I can get an RAC out as well. The magnitude of RAC should be the square root of 4 squared plus 6 squared plus 4 squared. Or this one's going to be 8.264 meters. Which takes care of that first step. I have my position vectors. I have their magnitudes. I have enough that I can get unit vectors for the both of those. So 2, let's get a unit vector. Unit vectors. So my unit vectors, I know a unit vector. I can say any unit vector is a full vector divided by the vector's magnitude. So I can say this is the position vector divided by the magnitude of a position vector. And I have these 2 times in here. My UAB, just following that form, would be my position vector, RAB, divided by the magnitude of RAB. Or this is 0I minus 2J minus 4K divided by the magnitude, 4.472. Which will get me here that this is UAB is 0I minus 0.447J minus 0.894 k. And one more unit vector. Let's do the same thing for u, a, c. This should get me RAC divided by the magnitude of RAC. Or that is my position vector. I know is 4i plus 6j minus 4k. And I can divide that by the magnitude, 8.264 over 8.264 meters. This will give me that my unit vector, the meters on top will cancel the meters on the bottom, give me a unitless unit vector, is going to be 0.484i, 0.484i, plus 0.726j minus 0.484k, which tackles my unit vector step. From here, I can just work towards a force vector. So come over on the side and say, let's get our force vectors. Force vectors will be my third step as I tackle this. Step 3, force vectors. A force vector, I can just say, is my force vector F is my magnitude of my force vector times a unit vector. I'm working towards this. My magnitudes, those are given, 600 and 500. My unit vectors, I just found. So I can get FAB, my force vector from A to B is my magnitude, 600, times that unit vector, 0i, minus 0.447j, minus 0.894k. And my units here, I have newtons times something that's unitless, so I should be getting newtons out for that. Or my force vector, and this is one of my answers. What is that 600 Newton force as a Cartesian vector? Should give me that FAB is equal to 0i minus 268j minus 537k. My units for all of that are newtons. And then I can repeat that process. My FAC, my other vector, should get me to, well, I have my magnitude of my force is 500 this time. 500 times my unit vector. And I know that, 0.484i. 0.484i plus 0.726j. 0.726j plus 0.484k newtons. Or my second force vector, FAC as a vector, is going to get me 242i, 242i, plus 364j, minus 242k. And my units for all of that should be newtons, which is my second answer. That also takes care of that entire first step here. From here, I need to get to my coordinate direction angles, alpha, beta, gamma. To do that, I need, and its magnitude, the resultant's magnitude. To do that, though, I need to get a resultant vector. So what is FR? My resultant vector is just, well, I have two vectors. I just need to add them together. So this is FAB plus FAC. Or coming in here, we're just going to add like terms. I have 0i plus 242j, or 242i. 0 plus 242i. Plus our two j components, plus negative 268 plus 364. J. And then same idea for our k, plus negative 537 minus 242k newtons for everything in here. Will get me, I can just combine my like terms. My resultant force, Fr, is going to get me 242i, 242i, plus 96j, 96j, minus, or 537 minus 242 is minus 779k newtons, which is that's not an answer for us, but it's a necessary step for us. If I know that as a vector, I can get its magnitude. I'm just using a 3D Pythagorean theorem that my resultant Fr as a vector should be the square root of 242 squared plus 96 squared plus 779 squared. Or my Fr, the magnitude here, which is one of the things. What's the magnitude of the resultant vector? Works out to be 821.35 newtons. Finally, if I know my components and my magnitude, I can get to alpha, beta, gamma. I can say that my cosine of alpha is the I component, 242, divided by my total magnitude, 821.35. 821.35. Or alpha works out to get us 72.82 degrees. Similarly, our cosine of beta should get me to my y component, 96, divided by my total force, 821.35, or beta, taking the inverse cosine of both sides. Beta is going to get me 83.29 degrees. And finally, my cosine of gamma should give me my k component. Don't forget to take that negative 779, divided by my total force, 821.35. Or gamma is going to work out to be 161.52 degrees. 161.52 degrees. Which is our very last answer on this. Our 3D problems can feel like there's a lot that we have to do to get through them, but just hold on to that idea of like no individual step in here really is terribly difficult. If we stay on top of everything, we have the ability to do these pretty doably. Go slow and steady on this. As you get more and more familiar with it, I would probably start trying to combine together my unit vector and force vector steps. Really, there's no reason to separate these out. I could just multiply 600 times RAB over RAB. It would combine together some of this work, but a lot of this is just repetitive writing. We can get through that. We can do it. I believe in you. If you found this useful, hit that like and subscribe button. Stick around. Let's get you an A with JJ.